Hi guys and welcome to Physics Series. Today we have a Specimen 2023 Paper 4 Question 8 Figure 8.1 is a circuit diagram. For part A, to calculate the combined resistance between Y and Z. Look here, which is 8 and 4 ohm, they connected in series. And they connected as well as a combined resistance with the 6 ohm in parallel. So to answer the question, to find out the combined resistance between Y and Z, so you have to find out a solution for the two resistors. They are connected in series now. So they are connected in series, as I said. So the RS for the total series or both combined resistors equals the 4 plus 8. So 8 plus 4 will give us the 12 ohm for the total combined series resistors, 12 ohm. I'm going to redraw the diagram again. So like this, the one which is on the top is the 12 ohm, and the one which is below here, which is the 6 ohm. If you look here, we have the junctions at the two ends, which represents the Y and Z, and the 12 and 6, they are in branches, are in parallel together. So in the second section here, the 12 and 6, both of them, they connected in parallel. So both 12 and 6 ohm connected in parallel. Show the examiner that you're familiar with this information. How can I find out the total two resistors, or the summation of these two resistors in parallel? So the 12 times 6 divided by the 12 plus 6. Which is R for the combined one, the series, times the one which is the 6 divided by the 12 plus 6. The multiplication of both two resistors, they are in parallel, divided by the summation of the same two resistors. It gives us 72 divided by 18, which is the final answer is 4.0 ohm. How can I mark my paper? For the 4 marks, 1 mark for the correct substitution, and the final correct answer for the first part for the series connection, and the third and fourth mark for the correct substitution, and the final numerical correct answer with the unit. And keep in your mind that we have two significant figures here. And one of the most important points, if there are two resistors connected in parallel, so the summation of these two resistors must be less than the least. So the answer is 4 ohm less than 6 ohm. This one happened always for if the two resistors connected in parallel. Section B here, to calculate the potential difference across the 8 ohm, the potential difference, which is the voltage. So I brought the diagram again for you here. So these two resistors, 8 and 4, the voltage across them, which is the 24. The examiner is asking to find out the voltage across the 8 ohm only. How can I find out this? They're sharing the 24 voltage, but they are not equal resistors to share the voltage equally. So there is only one formula to calculate this, which is the V1. Let me say the V1, which is across the 8 ohm, divided by the total voltage, which is across the 8 and 4, equals to the R1, which is the resistor 1, which is 8, divided by the total, or the summation of both resistors, the 8 and 4. The correct substitution is starting by V1, this is unknown value I'm looking for, divided by the 24 from the main power supply, equals the 8 for the first resistor, and divided by the summation of 8 and 4, they are in series. I already calculated from the previous step, is 12. If you do this one, it's easy to find out mathematically using the calculator to give us the 16 volt finally. The 2 marks, 1 mark for the correct formula with the substitution, and the correct final numerical, 2 significant figures with the unit. Thank you for watching.